This is the implicit homework video guide, and for question number 1, I need to take the derivative of 4y cubed. So this is very similar to the power rule. My power in this case is 3, and that gets soccer kicked to the front. So 4 times 3 is going to be 12, and then the y variable remains, and then we decrease the power by 1. So if I subtract 1 there, I get y to the power of 2. And then I need to multiply by I'm going to use the chain rule here, so I multiply by the derivative of the inside, and the derivative of y is going to be y prime. So there's our derivative for our very first question there. All right, so the derivative of y is just y prime once again. Okay, let's move on to question number 2 here. And for question number 2, I see a square root sign, so let's go ahead and rewrite that. So there's a minus sign, and then we have our y variable, and that's being raised to the power of 1/2. If I apply the power rule here, what that means is that this 1/2 gets soccer kicked and it multiplies with the negative coefficient there. So this will be negative 1/2 y, and then we decrease the power by 1, so this will be negative 1/2. And then this is where the chain rule kind of applies here. The derivative of y is going to be y prime. So that is our derivative right there. And if you want, we can rewrite this as, let me put an equal sign here. So equal sign, equal sign. Basically, the y prime here, we can kind of move that to the front. And then we can divide that by, and then we have a negative 1/2. So that's going to be a negative. And then if you want, you can put the 2 there, and the 1 is kind of like right here, right? So 1 times y prime. And then this part right here, that's the square root of just y. And then usually we just get rid of that leading coefficient and just make this negative y prime divided by 2 times square root of y. Okay, let's move on to the next one here. For question number 3, let's rewrite this as y to the power of -1. And if I apply the power rule, this negative 1 gets soccer kicked to the front. So this will be negative 1 times y to the power of negative 2. And then the chain rule states that you take the derivative of the inside, so the derivative of y is just y prime. Okay, so this is a correct answer here. If you want to rewrite this, we can. I'll put an equal sign here, so we'll take the y prime, and the y prime will be on the numerator, divided by, and then this part right here in green, that's going to be on the denominator squared, so y squared, and then this part right here can just be, we can leave a minus sign like that, and that should take care of it. Okay, question number 4, I guess we now have a product rule here, so there's 2x and y squared. So the derivative of 2x is going to be 2 times the second term, which is y squared, and then we add that to the first term, and the first term is going to be just 2x, and then we multiply by the derivative of the second term, which is going to be 2y times y prime. And that should do it. If you want to clean this up, I can write this as 2y squared plus 4xy times y prime. All right, so there you go for that particular derivative. All right, and question number 5 here, I guess we can apply the quotient rule here. So the quotient rule states that we take the derivative of the top, which is going to be 3x squared, and then we multiply by the bottom, which is y squared, minus the top, which is x cubed, and then we times by the derivative of the bottom here. So the derivative of y squared is going to be 2y times y prime. And then we divide that by the bottom squared, and if I square the bottom, we really have y to the power of 4 on the bottom, right? So if I just erase this, we should have y to the power of 4. Okay, so that's looking pretty good for that particular problem. I won't simplify any further, that's totally fine. Let's move on to a few more questions here. So I need to use implicit derivatives to find dy over dx. Okay, so step number 1, if you're taking the derivative, you should always start by writing d over dx, and then we're taking the derivative of everything here. So this is just a reminder that we are taking the derivative from left to right. And then let's go ahead and start taking the derivative here. So the derivative of x squared is going to be 2x minus, and then the derivative of y squared is going to be 2y times y prime, and then equals 2, and then the derivative of 9 is going to be 0. Okay, Now that the derivative has been taken care of, it's just an algebra game here. I can take this expression right here, highlighted in yellow, and bring that to the other side. If I bring that to the other side, I get 2y times y prime, and then I get 2x over here, and then I can divide both sides by 2y, and then we can just simplify this now. So this and this cancel, and then this cancels, and then we just have x over y on the left hand side, and on the right hand side we have y prime. Okay, this is a correct answer here. Sometimes you might see the answer be written like this as well. I can write dy over dx, and that can also equal to x over y. So you have some flexibility with y prime or dy over dx. So those are the same answers there. Okay, let's move on to question number 3 here. So I need to take this derivative here. So let me start off by first writing d over dx, and then we're taking the derivative of x squared minus xy plus y squared equals to 6. Okay, so let's start taking the derivative now. So the derivative of x squared is going to be 2x, and then we have a minus sign, so I'll put a minus sign there. And now we have a product, right? We have x times y. Now what I'll do here is I'll put a bracket here so that we take the product rule correctly here, and the derivative of x is going to be 1 times y plus x times, and then the derivative of y is going to be y prime. So there's our product rule that we've taken there, and I'll put a square bracket there to end it. And then plus, well, what's the derivative of y squared? Well, that's going to be 2y times y prime. All right, so it's really important that you do the first 5 questions of this homework video, guys, so that you're very comfortable with taking implicit derivatives here. And the derivative 6 there is going to be 0. Okay, that's our first derivative step there. And what we're going to do next is we have a minus sign here, and this minus sign will distribute into the bracket. So that will be my next line. So I have 2x minus y minus x times, I'll put this in y, red as y prime there. And then I have a plus 2y times y prime. I'm not sure why I changed all my colors here like that, but I think I just kind of got lazy there with the colors there, so we'll try to make sure that the colors are consistent next time. Okay, what we're going to do now is I see this term here and this term right here. So the two yellow terms, they contain the y prime, right? So what we're going to do is we're going to move those to the other side of the equation here. So if I move this term right here to the other side, that's going to be positive x y prime. And then if I move this term to the other side, I get negative 2y times y prime. And then I have just 2x minus y on the left-hand side. And then what I notice is that there's a y prime here and a y prime there. We're going to factor that out. So that's going to be y prime bracket x minus 2y. And then on the left-hand side, I just have 2x minus y. And then I can divide both sides by x minus 2y, and I can divide that by x minus 2y. And then from there, that cancels off, and then there is our final answer right there for that particular question. I also just want to say that sometimes there's different ways of writing this. So we know there's dy over dx, but depending on which side of the equation you moved y prime, sometimes the negative signs could change. Another equivalent answer to this is that you can actually flip this around. So this could be y minus 2x, and then on the denominator you can also flip that around as 2y minus x. And I would say that these two expressions here are mathematically the same thing. It just depends on which side of the equation you move y prime to. So in my case, I've been moving y prime to the right hand side. However, if I left y prime on the left hand side, I think I would definitely finish with this answer here, but both of them are mathematically the same thing. Okay, so move on to question number 5 here. So I've got this weird function here. So let's start off by writing d over dx. So I want to take the derivative of this function here, which is 2x cubed minus y cubed equals to x squared times y squared. Okay, so let's go ahead and take the derivative here. So what's the derivative of 2x cubed? Well, that's going to be 6x squared minus, And then what's the derivative of y cubed? Okay, well that's going to be 3y squared times y prime. And then that's going to equal 2. And then I have a product rule on the left-hand side here, right? So the derivative of x squared is going to be 2x times y squared plus x squared. And then I times that by the derivative of that, which is going to be 2y times y prime. Okay, so that's looking pretty good here. What I'll do here now is I guess I'll move the y primes to the left-hand side of the equation first, just to make sure that students can see like the differences here. So this part here in yellow, I'm going to move that to the left-hand side. And then this part here, which I'm highlighting in blue, I'm going to move that to the right-hand side. Okay, so if I do that correctly, I should get negative 3y squared times y prime, and then minus x squared bracket 2y times y prime, and I can close that bracket, equals to 2x y squared and then minus 6x squared. Okay, so there's the algebra right there if I interchange the yellow term and the blue term. And then we can kind of move on to the next step here. And what I see now is there's a y prime here and a y prime there. So let's go ahead and factor that out. So if I factor out the y prime, this is what we have. We have negative 3y squared minus, I guess the 2 can come up front, so 2, and then x squared y. So I'm just going to rearrange the colors there, and then I can close that bracket off, and then that's going to equal to 2xy squared minus 6x squared. And then I can divide both sides of the equation by this expression right here. So if I do that, I get y prime, and that's going to equal to 2xy squared minus 6x squared, all divided by negative 3y squared minus 2x squared y. Okay, so that should do it for that particular question there. And are there different ways of writing this particular answer? For sure. If I flip the so basically this is correct, and another way you could rewrite this so that it matches the back of the book is that you can rearrange this as negative 6x squared plus 2xy squared. And then what we're going to do is we're going to factor out the minus sign there. So if I factor out that minus sign, if I factor that out, then this becomes a minus sign. And then on the bottom here, if I factor out the minus sign, I would get 3y squared plus 2x squared y. And then what we're saying is that this minus sign, that will cancel off. And then you also have another answer just like that. However, my argument is both of these are mathematically the same thing. So if your answer doesn't match the back of the book, I can assure you they probably are mathematically the same thing. You just need to rearrange the expressions there. All right, let's move on to the next question, where we need to find the slope of the tangent line to each curve at the given point. So we're looking for the slope, right? We're not looking for the equation of the tangent line, we're just looking for the slope. So step number one, we need to find the derivative, right? So we must take the derivative of our given expression here. All right, so that's step number one. Let's take the derivative of that expression. And right from the get-go, I see that we need to apply the product rule here. So the derivative of x squared is going to be 2x. And then we times that by y plus x squared. And then the derivative of y is going to be y prime. All right, so that's our first derivative right there for the product rule. And then we take the derivative of negative x cubed, which is going to be negative 3x squared. And then we move on, and then we take the derivative of negative 4y cubed, which is going to be negative 12y squared. And then we times that by y prime. And then the derivative of 8 is going to be 0. And then we just make this equal to 0 at the very end there. Okay, so the next step here is that we know the point is 2, 1, right? So let me put this in bold letters here in red. Or sorry, maybe I'll use purple here. We know that the coordinate is 2, 1, right? So what we're going to do is that every time we see an x value, we're going to change all the x's with 2. And every time we see like a y, we're going to change all the y's with the 1 there. Okay, so hopefully that makes sense. And let me kind of erase this so that the colors are a little bit more clear. All right, so if we replace all the x's with 2, let's start over here. So 2 times 2 is going to be 4. Okay, and then if I plug in the 1 over here, that's going to be 4 times 1. Okay, great. And then plus. And then I guess we have 2 squared, which is going to be 4. And then 4 times y prime. And then we have a minus sign here, so minus 3 times 2 squared. And then I'll just continue to put all the numbers here. Minus 12 times 1 squared. And then we have a y prime over here. And then that equals to 0 there. Okay, so let's see if we can clean this up here, right? So this is going to be 4 plus 4y prime minus, well, this is going to be 2 squared, so 2 squared is 4, and 4 times 3 is 12, so minus 12, and then minus 12 times y prime. And then that's going to equal to 0. And our goal here is to solve for y prime, so let's go ahead and collect like terms now. So here's a 4 and a negative 12. So 4 minus 12 is going to be negative 8. And then plus 4y prime minus 12y prime equals to 0. Okay, let's go ahead and solve for y prime. We'll move the minus 8 over, so that'll become positive 8. And then 4y prime minus 12y prime is going to be negative 8. Right, so we're just taking a 4 minus 12, which is negative 8, and then we divide both sides by negative 8, so now you get negative 1.